video, we're going to talk about how ionic compounds are formed. We already discussed how atoms become ions. We said that the nonmetals gain electrons and become negatively charged anions. And we said that the metals lose electrons and become positively charged cations. We also said that we have two different types of metals. We have the fixed charge metals, group 1A, group 2A, aluminum, gallium, zinc, cadmium, and silver. Those have fixed charges. They never change when they become ions. We know immediately what their charge is going to be. And then we talked about the variable charge metals, the ones that could lose different numbers of electrons. And it depends on how many they lose, and that will be their charge. And I gave you a list of a few of them that you should feel comfortable with. All right, so now what we want to do is say, all right, how is it that a cation and an anion get together to form an ionic bond? Remember at the beginning I said that an ionic bond it basically occurs because there's a transfer of electrons. And that transfer of electrons causes one atom to become positively charged and one atom to become negatively charged. And it's the electrostatic attraction between these oppositely charged ions that creates that ionic bond. All right, so let's now show how that happens. What we're going to focus on are binary ionic compounds. The term binary means two elements. So we just have two different elements, not more than that. And we're going to create ionic bonds between those two different elements. So let's start off with one that you're already familiar with, sodium chloride, which is table salt. We have a sodium atom with one valence electron. And then we have a chlorine atom with 7 valence electrons. All right, remember the octet rule. Sodium wants to lose one electron, so it could have an octet. Go down to the second shell and have an octet and look just like neon. Chlorine wants to gain an electron so that it could look just like argon. Okay, so what happens? I'm going to use a red one. See this one electron of sodium? Remember how we said there's a transfer from the metal to the non-metal. So this comes right over here. Okay, so now what? Sodium lost an electron. It became a sodium ion. Chlorine gained an electron. It became a chloride ion. And this would be the Lewis dot formula of sodium chloride. Okay. Now, when we're doing reactions, when we're talking about sodium chloride, we rarely do a full Lewis formula like that. I just wanted to show you what is actually happening. But normally when I write sodium chloride, I just write NaCl. Look at this. No pluses, no minuses, no dots. It's just NaCl. That's sodium chloride. Okay, let's do another one. Let's say I've got calcium and bromine. Okay, calcium has how many valence electrons? It's in group 2A, so it's got 2 valence electrons. Bromine is a halogen, just like chlorine. It's got 7 valence electrons. Okay, now the calcium wants to give up 2 electrons, but bromine only wants to pick up 1. What's going to happen? You got to have 2 bromines in order for the calcium to manage to get rid of both electrons. So this one comes over here, and then this one comes over here. So what do you end up with? When the calcium lost both of its electrons, it became Ca2+. And then each one of these bromines is a bromide now. Bromide ion with a -1 charge, and then another bromide ion with a -1 charge. Okay? We don't ever show this. Whenever anyone talks about calcium bromide, you just summarize it as CaBr2. Notice no pluses, no minus. That is the formula for calcium bromide. Okay, so I just wanted to show you that there's an actual transfer of electrons. This is what is going on. But now let me show you how to do this fast. And I'll show you the no-brainer, easy peasy, no problem technique that you can all use for this class. Okay, so here's what you do. If I give you the name of an ionic compound, and mind you, whenever I give you the name of an ionic compound, you always write down the full name of the metal, and then you write down the name of the non-metal, the stem, with ending it with an "ide." So it's the stem of the name of the non-metal, and then "ide." So let's say I write lithium nitride. All right, so this is what we're going to do. Write down the lithium with its charge. How are you supposed to know the charge of lithium? Remember how we said group 1A metals, always +1. Group 2A metals, always +2. And then we said the other fixed ones are aluminum, gallium, zinc, cadmium, silver. Aluminum is +3, cadmium is +3, aluminum is +3, sorry about that. Aluminum is +3, gallium is +3, zinc and cadmium are both +2, and then silver is +1, okay? So lithium, group 1A, +1. What's nitride? Go back to the video talking about the nonmetals. Remember what we said. The halogens were all -1. The group 6A, oxide, sulfide, selenide were all -2. And then group 5A, nitride, phosphide, and arsenide were all -3. Remember that? Go back to that video. All right, so nitride is -3. I'm not going to put any dots. I'm just going to write it down this way. Okay? Now, how do I create a compound? The easiest thing you can do is just take the numbers, not the charges, just take the numbers. There's a 3 here and a 1 here, and crisscross them. It's called the crisscross technique. That's the no-brainer technique. So you bring the 3 here and the 1 here, and you get rid of the pluses and the minuses. So Li3N. You just created lithium nitride without showing electrons being transferred or any of that. If you wanted to show electrons being transferred, this is what you would do. You would have a nitrogen with its 5 valence electrons, and then you'd have a lithium with 1 valence electron. And then you would say, okay, I'm going to take this and transfer it here. But then you say, oh, but the nitrogen needs 2 more. So that means you're going to have a total of 3 lithiums, each one of them transferring 1 electron in order for the nitrogen to be okay. The point is, an ionic compound has to be neutral, no net charge. The pluses and the minuses cancel out. So when you do this crisscross technique, they always cancel out. So this is why I call this the no-brainer technique. This shows how the transfer occurs, but the net result is you have 3 lithiums to 1 nitrogen, which is exactly what this is showing. Okay? So the next video, I'll give you a whole bunch of ones to practice with, and hopefully you'll become really solid at this. Okay? Good.